After you write something, don't read it again for a week. You'll discover that it's terrible. Then write it again and look at it again in a week. And then maybe it'll get better. Think all the time. That's pretty funny. I mentioned study original sources. If you're trying to understand a theory, how many of you would like to understand evolution? Maybe you read The Molecular Biology of the Gene by Watson and Crick. I would say that maybe that's still the best book to read if you want to know about the molecular biology of the gene. It's completely out of date. It didn't know about spliceosomes, and it didn't know about, I think it knew about tRNA. What's the latest RNA? But if you read that source, it comes to life. Watson and Crick were doing it, and as they explain the stuff, you can see how they think about it. One of my professors was John von Neumann, and he wrote a book on the mathematical foundations of quantum mechanics. It's a big, long book. And the first 100 pages describes a part of mathematics called measure theory. And I read it like a detective story. It was so easy. I had read a book by another mathematician called Halmos on measure theory. It was incredibly hard. One reason it was incredibly hard is that Halmos was very orderly. All the theorems looked exactly the same with one word changed. If it's a semi-group, or if it's locally compact, then this. If it's compact, then that. Terribly hard. Von Neumann is telling this story about measurable sets and non-measurable sets. And actually, the book was written by some student who could write very fast. As in Feynman's great lectures on physics. Those were lectures that he gave, and they were transcribed and edited just a little bit. In this case of this von Neumann thing, he never edited the book. So it's very clear. It's very long, and you can read it 10 times as fast. When I read a real mathematics book, it takes me an hour a page. But you read this thing, and it takes an hour for 100 pages, and it's all clear. So what's all that about? Study original sources. Learn about evolution from Darwin, and you'll hear hundreds of wonderful stories. He didn't know about genes yet, but all the reasoning is modern. And that way you get the picture. And when people say, I can't see how a bird could evolve from one feather, how did a lizard turn into bird? Can you think of 3 theories? In the United States now, there are people who are teaching something called intelligent design instead of evolution, because they say the scientists won't tell you that there are difficulties in evolution. For example, no one can think of a way that an eye could develop with a lens. Well, these people are saying they're teaching students to be so stupid that they can't think of intermediate steps. And they want to be in the schools to teach children that you can't solve problems by thinking. Well, there are many theories. One theory is that some lizards jumped out of a tree. And you know, a small lizard can jump out of a tree and it doesn't get hurt because the terminal law. Small animals don't get hurt when they fall out of trees. One of my friends followed a squirrel around for a whole day. Ordinary squirrel. The squirrel fell out of trees 3 times. And so we presume that this happens frequently, but maybe it was sick. No. All right, so one theory is that the lizard developed the skill of jumping from one branch to another, and then if it got a little bit of anatomical change, maybe it could steer itself. The most popular theory today of how lizards develop flight is that there are a lot of small lizards that catch insects in the air. So the lizard here's the bug. The lizard jumps and catches the insect. They do this today. Well, as the lizard got faster, it could catch insects further away. But the problem is, if the insect moves, the lizard doesn't work. So what could you do? If the lizard had one little bit of skin sticking up, that it could move, attached to a muscle. And feathers are attached to muscles in general. So there's this little extra finger-like thing. Then when the lizard sees the thing move, it could make a tiny change. The answer is one feather is enough to make flight better. But half the people in the United States are instructed that it is impossible to think of anything like that. But now you have to think of 3 more. And that's the habit. You don't want to know the answer. You want to know 3 or 4 theories. So that's your homework. Think of 6 theories of how flight started. And after a while, it becomes a habit. I think I'm running out of good advice.